In this video, we are going to evaluate this expression. Let's consider the sum of this expression as equals to Sn. The denominator of each of the terms of this expression has the sum of the square root of two consecutive numbers multiplied to the sum of the fourth root of the two consecutive numbers. Let's consider the two consecutive numbers as n and n plus 1. Hence, here we have square root of n plus square root of n plus 1 multiplied to the fourth root of n plus the fourth root of n plus 1. Hence, the general term Tn of this expression can be written as 1 divided by square root n plus square root n plus 1 multiplied by fourth root of n plus fourth root of n plus 1. In the denominator, this fourth root is in the form of a plus b, where a is equals to fourth root of n and b is equals to fourth root of n plus 1. In order to reduce this fourth root into square root, we have to multiply the numerator and denominator of this expression by a minus b and a minus b here. A plus b multiplied by a minus b is equal to a square minus b square, which is equals to a is n to the power of 1 by 4 and square is 2 minus b is n plus 1 to the power of 1 by 4 and square is 2. So this gives square root of n minus square root of n plus 1. Now the Tn becomes Tn equals to, in the numerator we have a minus b, which is fourth root of n minus fourth root of n plus 1 divided by, in the denominator we have square root of n plus square root of n plus 1 multiplied by a square minus b square is square root of n minus square root of n plus 1. Now again the denominator is in the form of a plus b multiplied by a minus b, which is equals to a square minus b square. Here we have a is equals to square root of n and b is equals to square root of n plus 1. So this gives a square is n to the power of 1 by 2 and square is 2 minus b square is n plus 1 to the power of 1 by 2 multiplied by 2, and this is equals to n minus of n plus 1, which is equals to n minus 1, where the plus n and minus n will cancel out to give minus 1. Hence in the denominator we have minus 1. Now the general term Tm becomes fourth root of n minus fourth root of n plus 1 divided by minus 1, which we can write as Tn equals to minus of fourth root of n minus fourth root of n plus 1. For the first term we have n equals to 1 and n plus 1 equals to 2, and for the second term we have n equals to 2 and n plus 1 equals to 3. For the third term we have n equals to 3 and n plus 1 equals to 4, and for the last term we have n equals to 6 to 4 and n plus 1 equals to 6 to 5. Now the sum of the series can be written as the first term is minus of 4th root of n, which is 4th root of 1, minus 4th root of n plus 1, which is 4th root of 2. The second term is minus of 4th root of 2 minus 4th root of 3. And the third term is minus of 4th root of 3 minus 4th root of 4. Up to the last term is minus of 4th root of 6 to 4 minus 4th root of 6 to 5. Taking the minus signs common gives Sn equals to minus of 4th root of 1 is 1 minus 4th root of 2 plus 4th root of 2 minus 4th root of 3 plus 4th root of 3 minus 4th root of 4 up to 4th root of 6 to 4 minus 4th root of 6 to 5. Now each of these middle terms will cancel out because we have minus 4th root of 2 and plus 4th root of 2. They will all cancel out, leaving the first and the last term. Hence, this gives Sn equals to minus of 1 minus 4th root of 6 to 5. This is equals to minus of 1 minus, we can write 6 to 5 as 5 to the power of 4. To the power of 4th root is 1 divided by 4, because 5 to the power of 4 is equals to 6 to 5. Now this 4 and 1 divided by 4 will cancel out to give minus of 1 minus 5, which is equals to minus of minus 4, which is equals to plus 4. Hence, the sum of the series is equals to plus 4 or 4. This is our answer.